Now we're going to use calculus to find the area lighted by some street light, and we're going to do a lot of simplifications of this problem. Okay, we assume that this light is extending between these 2 points. So assume that this is the pole of the light. So the light is mounted here and it's lighting here. It extends to this point. Let's call it A, and this point B. And to solve this problem, we need to introduce some coordinate system. We're gonna call this one the x-axis, and this is the y-axis. Okay, and therefore this is our light here. Okay, it does extend here. This is a 3D view. Okay, so the light can light all these areas here. Okay, so it does extend to this one. We are trying to simplify the problem. We don't want to make it difficult. So we just want to see how we can use calculus to solve some simple problems. So here, what's the area? What's the area here that's being lighted by this light here? Okay, so if we assume that this is our coordinate system, and this point is B0, and this point is 0A, okay, and the light doesn't exceed this line here, okay, this line, because if we assume some other function, we need to find it to be able to integrate. And we can do it. You can find it using some kind of interpolation, polynomial interpolation, but we don't want to do that. We are just interested in finding this area lighted by our light here, and we assume in addition that this is some light, some line here that we can easily find the equation of it. Okay, so what we can do is we can simplify this equation. Okay, the equation here, we know the slope, we know the intercept point. We can simply say or write it down. Okay, but before doing that, before using calculus, we can even find the area lighted by this light. Okay, so we have, this is a rectangle here. Okay, but this is a triangle. Okay, this is a 90 degrees here, because we assume that we have a coordinate system. We have this point B, and we have this point A, and therefore we can compute this area. We know the area of a triangle. It's the height here is A, and the base is B. Therefore, the area should be AB over 2. So this is the area lighted by our light here. Okay, we assumed a lot of simplifications, but this is just an application of calculus. Now, to use calculus and find the area, we need to have to find the equation of this line. And I think if I do it correctly, the slope here is minus a over b. It's minus a over bx, and when we hit b, we get a. To hit b at the x-intercept, we need to have a here. Yes. Okay, yes. So I think this is the equation. Okay, now I need to integrate. So my function y of x dx, and I have to integrate between 0 and b. Okay, this is the quantity of light, the quantity of area that's been lighted by or been lit by this the street light. Okay, let's compute that and see if this is correct. If we made a mistake here and we get this area here, that means something is wrong. But let's do it anyway. So the integral between 0 and b, okay, you have a lot of b's, but that's fine. Minus a over bx plus a dx. So it's going to be minus a over b x squared over 2 between 0 and b plus a x between 0 and b. So we have minus a over b, b squared over 2 plus ab. Okay, let's do one more simplification. We have minus ab over 2 plus ab, and which is ab over 2. Yes, this is right. So we get the right thing. Okay, so we used a lot of simplification here. The model is linear, And the assumption is that the street light is lighting only this part. That's another assumption. But the aim is to see what calculus can do. Okay, we can do the model, the real model, but wait like 2 months. We're gonna see the real model, what we can do when we do multiple integrals. Thank you very much.